hello and welcome everyone. My name is Chad Hess. This will be the beginning of my math and physics YouTube channel. Of course, we'll be covering maybe a few other topics in there as well, maybe some chemistry, but that remains to be seen. For today, I figured the best way to start the channel would be to do some quarantine math. So maybe helping out those students, particularly high school students for this one, that are having a bit of trouble trying to get access to the tutors or classes. So I figured since I'm having a bit of trouble with that in university, I might as well share the math knowledge. So we'll be doing just a bit of algebra today. We'll do some algebraic manipulations, really just some like general SAT preparations, and then maybe I'll start another series on the channel, starting with Calculus 1 and working all the way up. You'll see we have a little Calculus 3 joke here, but it'll be a little bit until we get to that on the channel. So I hope you all enjoy, and let's get into the problems. All right, just one more thing I forgot to mention before we start the video. This is my special quarantine setup. My real supplies and my real board I left back at university, so I won't be able to get to those for about another month now. But we'll make do with this, and once I have all that stuff, it'll be great, and we'll get a better setup. But for now, we'll just be making do. All right, here we go. Here's our first problem. So you'll see we have a little function. So we have h over here, and that's going to be reliant on the variable y. So you'll see that h is equal to 3y plus 27.5. So in this case, the question asks that if a pediatrician who is measuring the height of a child is measuring within a certain span of years, and this is the function they use, how much is the height of the child changing with each year? So in this case, the most important thing, at least in my mind, is to start by defining what the variables are. So in this case, h, we'll pull that out here, h is simply equal to the height. So h is the height. Okay, so now, are there any other things we don't know? Well, we know 3. 3 is just a constant, that's a number. 27.5, it's a constant. So we need to define this y next, and this y is going to be years. So y for years. And this is really the first steps you want to take in any problem like this, especially if you're not sure where to go. Just start by defining the variables, and then the answer will very often just come out and make itself clear. So we have the height as a function of the years of a child. And this little constant out the back here, this is just the starting height. So at year 0, at the time the baby is born, if we plug in 0 into here, we get this 3 times 0, if y is 0, is equal to 27.5. So that means that at 0 years old, the baby must be equal to 27.5, I assume inches, but you know we're not given any units. Okay, so let's go about solving this problem. So we'll get rid of this. So remembering that h is height and y is years. There we go. All right. So if the question is asking us first and foremost how much the child's height is changing per year, well, we're going to find out that it relies on this factor, this coefficient in front of the y. A coefficient is just a number that comes in front of a variable. So in this case, 3 is our constant or our coefficient, and y is our variable. So that's just math terminology, but that's all that it was really referring to. So we can test this out. If we say maybe at year 1, how tall is the baby? Okay. So if we say h equals, and we plug in 1 for y now. So we say 3 times 1 plus 27.5. And that will equal 3. So because 3 times 1 will just equal 3. 3 plus 27.5, giving us 30.5. And that'll be our answer for if the child was 1 year old. So now, this is 30.5. I'm going to erase this, and I'll put at year 1, y equals 1 gives h equals 30.5. Okay, so we see that that's off to the side. This is just to remind us what values we found. All right, let's plug in another value. We'll see that h equals 3, and what's the year after 1? 2. We'll say now they're 2 years old. And we'll say, all right, plus 27.5. Well, that equals, so it's 3 times 2, 6, very good. 6 plus 27.5. And what will that equal? That's going to be 33.5. And that will be our answer if this child were 2 years old. So we'll put this off to the side. When y equals 2, we get that the height is equal to 33.5. And if we want to, we can keep plugging in variables as the years go up and see how much this changes by. But what I want us to focus on is just the two that we've already calculated. So remember, at an h value of 1, we found that the child's height is 30.5, and an h value of 2, or y value of 2, I'm sorry, not h value, we'll see that it is 33.5. This is a little awkward writing position for me, but okay. This is what we have. So now what we want to do, this little parentheses here, this is just to symbolize what variable for y we plugged in. So this just tells us h of what time in y, so what time in years, height at what year. So now we look at the difference between the two. All right, so what is the difference? What is the difference between these two numbers? I'll give you a second for that. And we'll see that the difference comes out to be 3. So now we can see that since our difference for each year is going to be 3, it's really this coefficient, like I talked about, that is going to be changing that. So if you get problems like this, you can, if you feel concerned or you might not understand the question, go ahead and plug in the first maybe 2 variables to test it out, maybe 2 or 3 until it becomes clear. Or you can just look and say, okay, this is going to be a constant value. That's not going to change with my years. However, this is going to change with my years. So let me give another very quick little sub-example. If this were, say, instead 2y, then this would be changing by 2 each year. Okay, so here we go. So if this were 2, then we can say that it changes by 2. And if you want, you can calculate that out. And I'll leave that for the viewer to do. But we'll see this will change our function by a factor of 2 for each year. So we'll go back to our original. And just give me a second. I'll erase the board and we'll come back with the next part of the question. All right, here we go. So the second part of the question is going to be asking us what the child's height would be. I'll put this in red so we know very clearly what it would be. So what is the height? Oh, the red's not working. Let's do this in blue and we'll work in black. Okay, so what is the height? So I'll put Q here. Q is this. What is the height at a year of 1.5? And then I'll equal a question mark. So what this is asking is what the height of the child is when they're 1.5 years old. So this isn't so easy. It's not just a natural number. It's not just an integer number like we had before. We weren't just saying 2 or 3 or anything like that. What we're now having to do is calculate this at a midpoint of the year. So this shouldn't be too hard. Don't panic if you see this. This looks a little daunting at first. I'll get rid of the Q just because that might add to some confusion. Okay, so what we want to find out is what the height is. You say this in mathematical terms, you say h of 1.5. But what this means is the height at a y value, the variable it depends on, at a y value of 1.5. Okay, Let's do this. Should be no problem. I'll put a little box around this so we know that's what we're solving for. And we'll move down here and we'll do our work. Okay. So we know the height equals 3 times y. And in this case, we know, well, we're given in the question that y must equal 1.5. So we'll plug in 1.5 plus, don't forget that plus, 27.5. Okay. A little bit messy, but you get the idea. So we need to calculate this out now. So we just now move this h down. We say h equals, what's 3 times 1.5? Well, depends what part of a test you're on here. You could use a calculator or you could do it in your head. But what we can maybe think is 3 times 1, well, that's 3. And half of 3 is 1.5. So we say 3 plus 1.5, that gets us to 4.5. So it's going to be 4.5, ooh, messy 5, plus 27.5. And what does that equal? 27.5 plus 4.5, well, we add the 0.5s together, we have 28 plus 4, and then 28 plus 4, what's that? That'll give us 32. 32. So 32 is our answer, whatever that's in. So we now can say that h of, or at a time of, 1.5 equals 32. So the child is 32 inches tall when they are 1.5 years old. All right, here we go. So we got the second problem here. So this writing is a little bit small. I won't blame you at all if you can't read it. This is mostly just a little note for me. So we have a system of equations. Whenever you see two equations like this, you have to understand this is going to be setting up a system of equations, which means you take one equation and another equation, and you put them into variables that you can plug in with one another, or things that you know are equal, and then you could calculate that to solve for a variable you wouldn't be able to otherwise. And this is a perfect example of that here. So this equation up top, it says that b equals 2.35 plus 0.25x. And the next equation says that m equals 1.75 plus 0.4x. So this b equation is the cost of bread. All right. Well, let's make this a little bigger. Okay. A little bit messy. There's the cost of bread. And this one is the cost of milk. Okay. Hopefully you can all see that. If not, not a big deal. I'll have to be rewriting this all anyway. So here's the cost of bread as a function. And here's the cost of milk as a function. This x variable is the time that we're measuring at. So we're maybe starting from a given time. That really doesn't matter. In the problem, it'll make itself pretty explicit. But we're given these two equations, and we're asked when the bread and the milk will have the same price and what that price will be. Okay, so this is a two-step problem, and we're going to approach it as such. So I'll erase this, and I'll come back to you with the first step. So what we're going to do is, since we know, remember, we have two equations, we're setting up a system equation in almost any situation, particularly the SATs, Algebra, Algebra 1, Algebra 2, whatever you're doing for that, if you get two equations like this, the first thing you should be thinking is to set up a system of equations. So that's what we're going to do. We know that these two equations must be equal. Why? Because this one is the price of bread. I'll put a little dollar sign here. Price of bread and price of milk. Well, we're asked, when are they equal? Okay, so what we do is we just say that they are equal to each other, solve for the x, and that will let us know. Right, so if that doesn't conceptually make sense, you can leave a comment. Maybe someone's already answered that question in the comments, and I will respond to it. Okay, so we say that the cost of bread and the cost of milk, which here's the cost of bread, right? Here's the cost of milk. We say that they're equal. Okay, so let's do this. We'll say that 2.35, I'm going to have to get in the way for a little bit, so sorry about that, plus 0.25x equals 1.75 plus 0 plus 0.4x. Okay, you'll see I dropped this 0 at the end because it's just a placeholder. It's not really doing anything in this equation, so I dropped it. If you like to keep it, you absolutely can. It doesn't change the problem at all, so don't worry about that. Okay, what do we want to do? So the first step is we want to get the x's on one side of the equation by themselves. Okay, so we could subtract this number from both sides, or we could subtract this number from both sides. So do we want to subtract 1.75 from both sides or 2.35 from both sides? Well, I would think it's easier to subtract 1.75 from both sides because that way we won't be dealing with negative numbers. So I don't want to deal with negative numbers. If you don't want to deal with negative numbers too, that's great because we're going to do it that way. But either way works. You can do whichever method you want. It's going to come out to the same thing. It's just that this way is easiest because you won't have to deal with negatives. But they're both right. So let's subtract. Let's do minus 1.75 on this side and minus 1.75 on this side. Okay, and you'll see these cancel. We have plus 1.75 and minus 1.75. That goes to 0. And this side, we have 2.35 minus 1.75. Well, what's that going to give us? That's 25, 35. All right, that's going to give us a difference of 60. So we'll say that what's left over is going to be 0.660, right? 60 cents in this case, plus 0.25x is equal to 0.4x. Okay, so now we've almost gotten everything simplified. Well, now we want to get the x's alone. And you'll see, I'll give you maybe a minute, how would you get the x's alone here? And you can pause if you'd like to keep thinking about it, but I'm going to keep going. So we can subtract the x's from this side on both sides, but then we'd have to move this around to the other side again. And then we'd be dealing with negatives, and we'd have to do an extra step. So let's do it the other way. Let's subtract this side from this side. Okay, so if we subtract, we say minus 0.25x and then minus 0.25x. Remember, if we do the same thing to both sides, then the equation is still valid. All right, so these are going to cancel. We're going to have 0.6 over here is equal to, what's 0.4 minus 0.25. Well, that's going to give us, all right, 0.15. I did a little cut there. I'm going to need to get down lower since we're moving down on the board. All right, 0.15x. Okay, we almost have x by itself. What else do we need to do? There's one more step. Can you think what we can do now? I'll give you a few seconds. If you'd like to pause, go right ahead. But here we go. So we're going to divide both sides now by this 0.15 because we want to get x alone. Remember, we can't subtract this because it's multiplied by another number. So when something is multiplied by another number, you can't subtract it unless you're moving the other number it's multiplied with as well. So we're going to divide both sides here by 0.15. You'll see these will cancel, but if we do it to one side, we have to do it to the other side. So this is going to be messed that up. 0.15 over here. And that is going to get us, let's see, 0.15 goes into 0.6. You can get the calculator out, or you can just know that it goes in 4 times. Either way, that will be what this answer is divided, and that is equal to, the only thing left over here is x, so x. So we see that x equals 4 when the equations are set equal to one another, which means, remember, x is time. So if x is time, then the time when they are equal is going to be at time 4. So if that's years or months or weeks, whatever it is, it's going to be at 4. Okay, so let's finish this off now. I'll come back to you. I'll erase the board and we'll finally hit the last part of the problem. Okay, here we go. So for the next part of the problem, we need to find out what the price is going to be when they're equal. So you'll see I've written up here, we know at what time they're equal. They're equal at x equals 4. That's great. But how can we find out the price? How can we find that out? I'll give you, once again, I'll give you a few seconds if you'd like to pause it. We're going to keep going here. So you could plug in x, or you can plug in 4 in exchange for x, since they're equal, in either of these two equations. So you can actually pick your equation. If you plug x in, if you plug in 4 for x here, you'll get the same result as you will if you get 4 for x here and you calculate that out. So I'm going to do the first one, and then I'll show you the second way, just so you know that it works for both equations equally. So here we go. All right, so B equals, remember, B is the price of bread, remember that, so this is the price of bread, is equal to 2.35 plus 0.25 times, remember, x is no longer just x, it is 4. Beautiful. And what does this equal? All right, so we still got 2.35 plus 25, or 0.25 times 4. That's going to give it just 1. And this will equal 3.35. And that is our price of bread. So we solved the problem. It's 3.35. But let's model this. And let's look at the other equation just to make sure. If this is correct and we calculate this right, then we should be able to plug it into both equations and get an equal price value. So I'll do the price of bread equals 3.35. Okay, this should be equal to the price of milk. Okay, so here we go. Price of milk equals, all right, it's 1.75 plus 0.4x. All right, but we can replace this x, remember? We can replace this with a 4. There we go. Perfect. Now let's calculate this out. This is equal to 1.75 plus, and then 4 times 0.4. That's going to give us 1.6. 1.6. You can either do that with a calculator, or you can just say that 4 times 4 is 16, and there's one decimal place. So you move this decimal from here over to here. There you go. 1.6. Okay. And 1.75 plus 1.6, that will equal, so there's our 2, there's our 6, that goes in, now equal 3.35. And you'll see that is, in fact, equal to the answer we got over here. Therefore, this is correct. So here's the value when they are equal, and here are the prices at that point. All right, that's going to wrap it up for today's video, everyone. I hope you enjoyed. If I'm covering the content you like, that's wonderful. I'm super glad. But if not, please let me know in the comments. I really will cover any math, physics topic, anything that you guys want. So any level, really up to college level. I'm a university student for majoring in physics right now. So I can cover your small questions, your big questions. Just let me know. All right, I hope you guys enjoyed the video. And I will see you very soon.